Alright, so again, homologous series is a family of organic compound which follow a regular structural pattern in which each successive member differ in its molecular formula by a CH2 group. And examples of homologous series are alkanes, alkenes, alkynes, alkanol, alkanals, and alkanones, right? So here we're going to look at the different homologous series and their general molecular formula. Alright, so here we have 10 examples of the homologous series and we have their general molecular formula, right? So first we have the alkanes. This is the simplest homologous series. Alright, this is the simplest homologous series and the general molecular formula is CnH2n plus 2. We have the alkenes and the general molecular formula is CnH2n, right? We have the alkynes. The general molecular formula is CnH2n minus 2. We have the alkanols. The general molecular formula is CnH2n plus 1 OH. Alright. We have the alkanoic acid, which are also known as the carboxylic acid. And the general molecular formula is CnH2nO. We have the alkanoids, which are referred to as what? Esters. Alright. And the general molecular formula is CnH2nO. Then we have the alkanals. They are also called aldehydes. Alkanals are also called what? Aldehydes. And the general molecular formula is CnH2nO2. We have the alkanones. They are also referred to as what? Ketones. Another name for ketones are the alkanones. Another name for alkanones are ketones. Alright? And the general molecular formula is CnH2nO2. We have the ethers. Alright? And the general molecular formula is CnH2n plus 2O. We have the primary amines, and the general molecular formula is CnH2n plus 3N. Right? So these are different homologous series, and these are their general molecular formula. So it's very important that you know the general molecular formula of the first homologous series or the simplest homologous series, which is the alkane. So it's very important that you know this general molecular formula for the alkane. It's important that you know this as well for the alkenes, and it's important that you know this for the alkynes. It's important that you know this for the alkanols. It is important that you know this for the alkanoic acid. So alkanoic acid and alkanoids, they have the same general molecular formula. Alright. Then the alkanals and the alkanones, they have the same general molecular formula. Alright. So these two are the same. These two are the same. So it is important that you know this and know this as well. Alright. So alkanoic acid and alkanoids, they have the same general molecular formula of CnH2nO. Alkanals and alkanones have the same general molecular formula of CnH2nO2. Alright. And you can use this to find the molecular formula of any member of the series. For example, if we have pentane, pent is telling us that there are 5 carbon. Alright. This is the 5th member of the alkane series, pentane. Alright. So since this is pentane, there are 5. This is the 5th member of the series. That means our n is equal to what? Is equal to 5. Alright. So if I put this n equal to 5 into this general molecular formula of CnH2n plus 2, what I'm going to have is C5, right? Because my n is what? 5 for pentane. H2 bracket what? 5 plus what? 2. So this will be C5. 2 times 5 will give me what? 10. 10 plus 2 will give me what? 12. So that's C5H what? 12. This is the molecular formula for pentane. All right. This is the molecular formula for pentane. So you can use this formula, you can use any of this formula to look for the molecular formula of any member of the series. All right. So if we talk of hexane, hexane. So here's here is telling us that this is the sixth member of what? Of the series, of the alkane series. So my n will be equal to 6. So when you put in your value of n equal to 6, you are going to have the molecular formula of the hexane. Alright. Octane is telling us that the number of carbon atom here is what? 8. Octane. So if you put your n equal to 8, you are going to have your molecular formula for this octane. Alright. So it's very important that you know this. So next we are going to look at the characteristics of the homologous series.